Today I want to talk to you about compound interest. I know we've already done compound interest when we were working on with logs, but we're going to talk about compound interest in terms of sequences and series today. All right, so for example, if we consider an investment of $1,000 that earns 10% interest compounded per annum. I know that's a weird European way of saying per year. But you need to see it because if you take the IB exam, that's what it will say. After 3 years, how much will you have? Well, if we think about it, oops, need to get my pen out. Our initial value or our starting value is $1,000. Then after 1 year, we have $1,000, and then we multiply that by 1 plus or minus the rate. 1 plus or minus our rate in decimal. If it's plus, then we have growth. If it's minus, then we have decay. In this case, we're gaining, so it's going to be 1 plus the rate. The rate is 10%, so it's going to be 1.1. That's 1 plus 10%. And that's going to be to the first power. After 2 years, we have $1,000 times 1.1 times another 1.1 because we have what we started with or what we had last year, and we multiply that by 1.1, and that's equal to 1,000 times 1.1 squared. Okay. After 3 years, we have 1,000 times 1.1 times 1.1. That's what we had last year. And then we're going to multiply that by 1.1 again. So we end up with $1,000 times 1.1 to the third. That's how much money we have after 3 years. So that suggests that after n years, we have $1,000 times 1.1 to the n. And that brings me to the compound interest formula. So if I think of my first term being u sub 1 or a sub 1, it doesn't matter. That's my initial value. And when we were working with the last problem, that was $1,000. Then my second term is going to be the initial value times the rate, or 1.1 in that case. My third term was the first term times 1.1 times 1.1, which is my first term, times 1.1 squared. Then my fourth term is my first term times 1.1 times 1.1 times 1.1, which is my first term times 1.1 to the third. So if I want the nth term, or if I want to know how much money I have after so many years, in this case it's 3 years. If you look here, this is one more. So this is u sub n plus 1. This is all subscript. The u is not. That's going to be equal to my first term times the rate to the nth power. So that gives me the value after n years. So this is the value after n years. This rate here, that's called the multiplier. Or actually, in this case, it's the growth multiplier. And then, so u sub 1 is my initial value. R is the rate, or the growth multiplier. N is the number of years, or number of units of time. Usually it's years, but it can be something else like weeks or days. And then u sub n plus 1 is the amount after n years. Since we've worked with sequences and series before, I'm going to have you try this one. Go ahead and stop the video and turn it on when you're ready. All right, so using our formula, u sub n plus 1 equals u1 times the rate to the nth power. So we're looking for time after 4 years. 4 plus 1 is 5. Initial value in this case is $5,000. The rate is 7%, and it's growing because we're compounding, we're investing at a rate of 7%. That's going to be 1.07. And then to the n is just 4. When I calculate that out using my calculator, I get 6553.98. And you'll notice that because I'm dealing with money, I use 2 decimals, right? Because we can have cents. Nothing else would make sense. Ha ha, get it? Okay. You'll notice I have a money tree over here. That's because I need to buy a sewing machine. So how much should I invest now if I want the maturing value to be $10,000 in 4 years' time if I'm able to earn 8.5% compounded per annum? Wouldn't it be nice if money grew on trees? Actually, it'd be even better if sewing machines grew on trees. Oh well, I guess I'll have to calculate the problem. All right, so in this case, I want my end value to be $10,000. What I don't know is my initial value, and I want this to happen in 4 years' time, and I'm earning a rate of 8.5%, so that's going to be 1.085 to the 4th. So what I need to do is divide 10,000 by 1.085 to the 4th. So I can't separate this because this belongs together, but I can separate it from the U1, and that is going to leave me with my initial term or my initial value. And that means that I need $7,215 and, oops, that should be a decimal, 74 cents. Yikes, that's a lot of money. Okay. Last bit of notes tonight, one for you to try. Turn this off and try it, turn it off and turn it back on when you're ready. We have the initial population of rabbits on a farm was 50. The population increased by 7% each week. How many rabbits were present after 15 weeks, 30 weeks, and then how long will it take the population to reach 500? Notice that your time here is in weeks, so that's okay. You're just going to give an answer in terms of weeks. All right, so we want to know how many rabbits after 15 weeks. So my 16th term is going to be 50 times, and we increase by 7%. So my growth multiplier is 1.07, and after 15 weeks, it's going to give me just really close to 138 rabbits. In this case, you want to round up or down because you won't have a partial rabbit. Okay, so after 30 weeks, we're looking for the 31st term. And we have 50 times 1.07 to the 30th. And that leaves me with about 381 rabbits. How long would it take the population to reach 500? Oh, you're going to like this. Why? Because we just got done with logs, and you're going to need logs for this. All right, so I have 500 equals 50 times 1.07, and what I don't know is the time, so that's to the n. The first thing I'm going to do is divide both sides by 50. And that gives me 10 is equal to 1.07 to the n. I'm going to take the log of both sides. That exponent can come down in front and be multiplied. Notice though that this is 1. Log of 10 is 1. So 1 is, you know what, I'm going to erase this. There's a lot of stuff there. I'm going to go back over here and erase it. So 1 is equal to n log 1.07. Now I can divide. Log of 1.07 is a number, so I can go ahead and divide both sides by log of 1.07. Oops, that's not an eraser. That's not either. How about this one? Better. Which means that n is about 34 weeks. Okay, great. Hope you're ready for class, because there'll be a quiz on this.